video, we're going to find linear relationship. So in this data set, we're going to use graduate admissions. And we want to know if there's a linear relationship between GRE scores and the chances of being accepted in a master's program. So here you can see all of their GRE scores. And then over here, we have chance of admit. So this is their chances of being accepted and being admitted into the college. So we're going to go through these 4 steps, and we're going to see if there's a linear relationship between these two things. So first off, we want to make a scatter plot. And we can also actually find all of these steps here in one calculator in StatCrunch. So I'm going to go into Stat, Regression, Simple Linear, and I'm going to choose our GRE scores and see if that's going to influence our chance of admit here. So then you can see it has our hypothesis written down for us, and we have everything else we can just leave as is. So once you put in your x and y variable, you can go ahead and hit our submission. It'll let me get to the submit button. So here we commute, and after we compute, we get our simple linear regression results. So the first thing we want to do is click on this arrow, and this arrow will give us our scatter plot. So this is our scatter plot. If you want to take a screenshot, I have a Mac, so I can do Command-Shift-4, and I'm going to put this here. So Command-Shift-4, it gives us our screenshot, and then I'm just going to put this into the Word document. If you don't have a Mac, you can use your snippet tool and also get your screenshot to go in here. So we have, this is our step 1. So we've created our scatter plot. And we can see that this is pretty close to the line. We can tell it's a positive relationship here. So there's no patterns, no parabola, U-shapes. So pretty straight line. So we're good there. So we're going to move on and calculate the correlation coefficient. So now step 2, calculate our correlation coefficient. We're going to press the back arrow. We can see that our correlation coefficient is right here. So correlation coefficient is 0.80, about 0.803. And this is pretty high correlation. So we have our R is about 0.8. What this R squared here is the amount of variation explained. So about 64% of the variation in the chance of admission is explained by the GRE score. So that's also pretty high. So next we're going to write out our null and alternative. And remember, it's always the same for our correlation tests. So we have, it's always our null is the row, the funny looking P, equals 0, and our alternative is it does not equal 0. So this one, as a freebie, you should always get this question right. So row does not equal 0. So then we're going to look at our p-value. I want to look at the row for the slope here. So we say our p-value is less than 0.0001. And the test statistic is this number here. So the t-stat for our slope, because we're testing to see if this line here, we're testing this slope. So we have test statistic is this value here, 26.8. And we want to compare our p-value to our level of significance. Just going to say, I didn't say it up here, but I would say alpha is 0.05. So we're going to compare and see. So we have p is less than 0.0001, so that's very small, which is less than 0.05. So this means we reject the null. So since we reject the null, that means there is a linear relationship. So there is linear relationship. And going to write that out in the context of the problem. So there's a linear relationship. So in this context of this problem, we're going to say there is a linear relationship between GRE scores and the chance of being admitted to a master's program. Which makes sense. You have higher GRE scores, you're more likely to get into the master's programs. So that is how you figure out if you have a linear relationship. You can also, we'll find out in future videos, find our equation, which would be right here. So that's our linear equation for this line that we created. But we will go over that in future videos. This one will tell us how to find if there is a linear relationship.